doing the second half of Chapter 2, Section 2, and that is deductive reasoning versus inductive reasoning. Deductive reasoning, instead of using patterns and things like that, uses facts, definitions, accepted properties, and laws of logic to form a logical argument. So not using patterns, but now using facts. There are two basic laws of logic we talk about here. The laws are called the law of detachment and the law of syllogism. Those are big words, especially syllogism. But we'll get to them pretty quickly here. They're not that tough to figure out. Law of detachment says this: if the hypothesis of a true conditional statement is true, the conclusion must also be true. So in other words, if I know I have a true conditional statement, like if it is raining, then I will carry an umbrella, and it's raining outside, so the hypothesis is true, then the conclusion must follow, I will carry an umbrella. So if I know that a conditional statement is true, and the hypothesis happens, the conclusion must follow. The law of syllogism is really transitive property for geometry. Syllogism, if P leads to Q, and then if Q leads to R, then P must lead to R. This is the old, if you give a mouse a cookie, or if you give a moose a muffin, or those books that you grew up with when you were little, where they started with a premise. If you give a mouse a cookie, then he's going to want some milk to go with it. If he wants some milk to go with it, then this is going to happen. If this is going to, it leads to this long chain of events, and often to, in our children's books, a very silly conclusion. That's syllogism. So a silly conclusion after a chain of events is a syllogism. It's not a syllogism, syllogism, but it helps you kind of remember what's going on. Okay? We can do this all day, make up little syllogism games and have fun with it. The thing we have to be very careful about with syllogism is that the order has to be specific. Okay? If P goes to Q and then Q goes to R, that's a syllogism. If I have something where P goes to Q and P then goes to R, there's no necessary relationship between Q and R. It has to be an actual chain of events, an unbroken chain. This has to be a Q in order for there to be syllogism. So be careful if you get a series of statements to make sure that everything is proceeding in the correct order and that there is an unbroken chain. You have to read carefully. So here's an example. If two segments have the same length, they are congruent. You know that BC is equal to XY, meaning they have the same length. What must be true? Well, by definition, therefore BC has to be, segment BC has to be congruent to segment XY. If two segments have the same length, which they did, then they are congruent. Aha! That's what our conclusion was. That's law of detachment. It's really that quick and easy. Can I use law of syllogism here anywhere to make some conclusions? If x squared is greater than 25, then x squared is greater than 20. If x is greater than 5, then x squared is greater than 25. Well, at first glance we say, well, no, because this leads to that. That's fine. But in order to have syllogism, then this statement here would have to be the first statement over here, and it's not. So it might be tempting to say, no, no syllogism. But what if we take the other statement first? If x squared is greater than 5, then x squared is greater than 25. So my next statement would have to start with that. Ah, it does. So I do have a valid chain of events. And my conclusion would therefore be if the first statement, x is greater than 5, then the last statement, x squared is greater than 20. So a little bit tricky. We have to examine all the possibilities. I can't switch the order of a statement, but I can switch the order of the statements themselves. Nothing said that this has to be my first statement, and this is my second statement. We can switch that order around. Just within the statement, I can't switch to a converse. That's not allowed. If a polygon is regular, then all the angles in the interior of the polygon are congruent. If a polygon is regular, then all its sides are congruent. Okay. So, is there a syllogism here? Well, let's see. Polygon is regular, then all the angles in the interior of the polygon are congruent. So, in order to have syllogism, this second statement, all the angles, has to be the first statement in the next thing. It's not. Doesn't look like syllogism. Well, let's try it the other way. Let's do the other order. If a polygon is regular, then all its sides are congruent. Okay, if all the sides are congruent, is that the first statement? It's not. Do I have a syllogism? No, I don't. No conclusion. Now, I know some of you are saying, but the first statements are the same. Yeah. Polygon is regular if a polygon is regular. These two are equivalent, but that doesn't help me because that's not a legit chain of events. Not A to B, B to C, C to D. This is A to B, A to C. That doesn't work. It has to be A to B, B to C. Now, so we kind of talked about syllogism and detachment. Let's decide. Are we using deductive or inductive reasoning? Now remember, deductive reasoning is based on facts. Inductive reasoning is based on observation and patterns. It's usually pretty easy to tell the difference between them, but let's just take a look at a couple examples here. Each time Monica kicks a ball up in the air, it returns to the ground. So, next time Monica kicks a ball up in the air, it will return to the ground. It's a valid conclusion, or so it appears to be. I mean, it could get stuck in a tree or something like that, I suppose. But what is she basing her conclusion on? What is Monica basing this conclusion on? Is she basing it on facts? Or is she basing it on observations of things that have happened in the past? In this case, it's pretty clear she's basing it on observations. And since it's based on observations, this is an example of inductive reasoning. It's also a false conclusion. Like I said, it could get stuck in a tree. It could land on the roof. Gravity could fail entirely. You should kick it hard enough that it reaches escape velocity and actually leaves the Earth's gravity well. Yeah, that's not very likely. But could happen. No, not really. Nonetheless, it's based on inductive reasoning and observations. It's not based on science, facts, or anything like that. Part B, all reptiles are cold-blooded. Parrots are not cold-blooded. Sue's pet parrot is not a reptile. Okay? Is that statement not evaluating truth or falseness of it, but is that based on observations or facts? In this case, all reptiles are cold-blooded. That is a fact. Just a fact about reptiles. Parrots are not cold-blooded. Sue's pet is not a reptile. This is deductive reasoning. That is an example of deductive reasoning. If the measure of angle R is between 90 and 180, then R is obtuse. The measure of angle R is 155. Using the law of detachment, what statement can you make? Well, law of detachments tells me, number one, that it's deductive reasoning because I'm using law of detachment. And the conclusion I can make, well, since it's between 90 and 180, the conclusion I can make is angle R is obtuse. And that's deductive. Next one says, use the law of syllogism to write a new conditional statement that follows from the pair of true statements. If you get an A on your math test, you can go to the movies. If you go to the movies, then you can watch your favorite actor. Is it legit syllogism? A in the math test leads to go to the movies. The next statement starts with what this statement ends with, go to the movies. We do have a chain. Then You can watch your favorite actor. Therefore, I can use law of syllogism to shortcut this. If you get an A on your math test, then you can watch your favorite actor. Then you can so that's what syllogism does. Use inductive reasoning to make a conjecture about the sum of a number in itself, then deductive reasoning to show that it's true. This is a much more complicated thing. Okay? Inductive reasoning would be based on a pattern. So let's say, let's look at some patterns. 1 plus 1 equals 2. 2 plus 2 equals 4. 3 plus 3 equals 6. It would appear that the sum of a number itself is always twice the number. That's inductive reasoning. To use deductive reasoning, we'd have to use what's called a general case. We can't use specific examples. So I'd represent my number as x. X plus x equals 2x. Aha. By definition, that's a true statement. Facts of algebra tell me that x plus x equals 2x. So the sum of any number in itself is twice that number. This is using deductive reasoning. That's a bit harder. And that's something I'm not necessarily going to expect you to be especially fluent in at first. Finally here, decide whether inductive or deductive reasoning is being used. To reach a conclusion, explain your reasoning. These are a little tricky, but let's take a look at it. All multiples of 8 are divisible by 4. Is that based on mathematical facts? If it's a multiple of 8, it's also a multiple of 4? I would say yes. That is a mathematical fact. Anything that's a multiple of 8 is also a multiple of 4. Since I'm using mathematical facts to make that conclusion, I would say I'm using deductive reasoning. However, if you did it by finding several examples, it's possible for you to do that inductively by finding several multiples of 8 and showing that all those multiples of 8 are also divisible by 4. So if you did many examples using specific numbers, then you'd be using inductive reasoning. So you could do that either way. 64 is a multiple of 8. That's a fact. That would be deductive reasoning. So 64 is divisible by 4. Okay. 64 is divisible by 4. Yes, that's a fact also. So it looks like if we put all of these together, if this is a fact and this is a fact, then that's a fact. I would say as a whole, this is all going to be deductive. So again, basing on facts and not on patterns, that's deductive reasoning. All right, this is a tricky subject, and it's one that we're going to spend plenty of time with talking about in class. So if you need extra help with it, please be coming in to see me before or after school, be using the Learning Center, whatever is necessary. Make sure you are getting the help you need to make sure you understand what's going on in class. I will see you in class.